All right, we're going to talk about variation, and this is on, let's see, page 57 of your yellow pages. So there's some vocabulary that I want to teach you: direct variation, indirect or inverse variation, and joint variation. So with direct, an example would be the distance I travel is directly related to the time that I spend. So as I spend more time traveling, the miles that I've gone increase. Okay, and so that with direct variation, as one quantity gets larger, the other one does as well. Okay, and the setup for these is an equation that might look like y equals k times x. And there's going to always be some sort of a constant of variation. Now, indirect is not, it's not as one gets bigger, the other gets bigger. Instead, as one gets larger, the other quantity is actually getting smaller. So the setup for these is you're going to be dividing k by your x, or whatever the variable stands for. An example might be the amount of warm clothing I need to wear varies inversely with temperature. So as I get warmer, I need fewer and fewer warm clothes. And then sometimes there's a combination of different quantities, and that's a joint variation. So let's do an example. So the electrical resistance on a wire. So the resistance on a wire is directly proportional to its length. Okay, and I see those words directly proportional. So in my head, I'm thinking of that setup, y equals some constant times x. But the story isn't about y and x. Instead, it's about resistance. And it's about length. So my equation is going to be the resistance is directly proportional. That means k times the length. Now I can figure out what k is worth by using the next sentence. So in this next one, we're given a length and a resistance for that particular length. From that information, from that example, I can plug those variables or those amounts in. 35 feet is my length, so I'm going to plug in 35, and I have the resistance of 2 ohms. So plugging that in, I'm going to be able to figure out what k is worth. So let's go ahead and do that. We've got 2 for resistance. I don't know what k is worth. And then in this example, I have 35 feet. So I'm going to solve that. The opposite of multiplying by 35 is to divide both sides by 35. 35 divided by 35 is just 1. And so then that allows me to figure out what k is worth. K is 2 over 35. And that is approximately, let's see, get my calculator. That's approximately 0.057. Okay, now let's think about our units. That 2 was ohms. There's I'll actually just write it out. Okay, ohms. And then that 35 was feet. Okay, so now my formula is going to be exactly what I have up here in step 2. But in step 3 now, because I know what k is worth, I can copy this down. And it goes like this, k times L, but now I know what k is worth. Okay, so it's going to be 0.057 times L. And finally, now I get to actually answer the question. So in step 4, I am answering the question. Okay, let's figure out what the question is. Work through the steps. Okay, here it is. Find the resistance of a 100-meter wire. So I think, well, maybe I can just plug 100 in here for length, but it's not going to work quite yet because that is 100 meters. And our units were in feet. So let's first convert 100 meters to feet. Okay, let's see. I don't want meters, right? I want, let's see. All right, so let's see, we've got 3.3 feet is in 1 meter. So I want to get rid of meters. I'm going to put that in the denominator, and that's the same as 3.3 feet. Okay, so now I have a number times a fraction. So my number goes, I can give it a denominator of 1. So that meter is in the numerator, and it's going to cancel because meters over meters is just 1. So my meters cancel, and now I have that is approximately 330 feet. Okay, so that's what's going to go in for L. So I'm going to plug that in and put that right in for L, and then I'll be able to find the resistance on that wire. Okay, so step 4, we're going to find the resistance when we take our constant of variation, which in this case is 0.057 times our 330 feet. And my units on that K, the units are ohms per feet. So when I multiply that by 330 feet, my feet cancel and my units are just ohms, which makes sense. Okay, so now we get, see, so that is approximately 18.8 ohms. All right, so what did we do? In step 1, we figured out what the story is about, defined our variables. In step 2, we figured out how to set up our equation based on that words, the direct, indirect, or jointly proportional. And step 3, we figure out what K is worth and plug that into our formula. And then finally, in step 4, you can actually answer the question. Okay, let's try another one. Interest varies jointly as principal and time. Okay, so what's the story about? It is about money, interest, principal, that's how much money we invest at the beginning, and time. All right, I'm seeing varies jointly. So what comes to my mind is that setup that goes like this, y equals x times, or sorry, k. We always have some constant of variation. Okay, but our story isn't about y's, x's, and z's. Instead, it's about interest, it's about principal, and it's about time. So I'm going to define my variables. And time is in years. So I kind of read through and I can figure out my units here. And interest is in US dollars, it looks like. Okay. That was one thing that I didn't do here is I would want to make sure that I'm showing that the units there are in feet, the units here were in ohms. So it's good to make sure that we have our units defined there as well. Okay, so step 1 is done. We figured out what the story is about. Step 2, we're going to figure out how to write our equation. So it's joint, so I get to multiply those variables. And I'm going to have the first thing that came was interest. So that goes on the left side of the equation. And then it says varies jointly. So that means K times whatever comes next. And in this case, I have principal and time. All right, now it's my turn to figure out what K is worth. And we do that by reading through and finding the sentence that has everything defined with numbers. So in this particular example, we have a 2,000 amount. So that's my P. In this just particular example, 4 is my T and 320 is my interest. Okay, so that's just an example. but that's going to allow us to figure out what K is worth, what K is worth. So I had 320 of interest is what I get when I take $2,000 and invest it for 4 years. And solving that, I've got 2,000 times 4, so that's 8,000 times K. Now I want to get K by itself, so I'm going to divide by 8,000. And when I do that, I find out what my K is worth, which in this case is, let's see, about 0.04. All right, so in step 3, I am figuring out what K is worth. Okay, and then I take what I just found in the way that that formula is set up. The formula itself is going to include the value of K. Okay, so I'm going to type, or I'm not type, but write just what I had up here in step 2. The only thing is that instead of K, I now know what it's worth. And that's times principal times time. So there's my formula. And finally, in step 4, I get to solve. And the question is, find how much interest would be earned if I deposit 5,000 principal for 7 years. Okay, here we go. So interest is going to be 0.04 times my principal, which is, oh, I just forgot it, 5,000 for 7 years. 5,000 for 7 years. And that gives us a grand total of 1,400 for interest. Okay, free money. So step 4 is when you finally answer the question. Okay, let's do one more. All right, the force required to turn a wrench when we're gripping right at the end is inversely. So we've got force is inversely proportional. So what's coming in my head is that equation set up where we're taking our constant and dividing it by x. But our story isn't about that. It's about force, and it's about the length of a wrench. And I'm seeing feet, and I'm seeing pounds. So let's define our variables. F is for force in pounds, and length is, or L is going to be length in feet. All right. So step 1, I figured out what the story is about. Step 2 is to figure out what the setup is going to be. It would be force is, there's my equals, directly proportional to, so that, or inverse. Ooh, I almost made a mistake there. Inversely. Okay, so we're going to take, the thing that comes next is length. We're going to take K and divide it by that length. Okay, our next job is to figure out what K is worth, and we do that by using the example. So let's see, a certain bolt is so tight that it uses 1 foot wrench. You'd have to apply 512 pounds of force. So my force would be 512. I don't know K, but I know that the length is 1 foot. All right, so K is 512, right? Because that was just divided by 1. So K is 512. And my formula is force is equal to K divided by L. But that is, now I know what K is worth. Okay, so we did step 3, figured out what our K is worth, wrote the formula. Good, and now I get to finally in step 4 answer the question. So the question is, if you have strength for 150 pounds of force, So you decide to slide a pipe over the wrench to extend its length. Working through the steps below, find the minimum length. So what I need to know is the length that you need to loosen the bolt. So what I want to know is length. Okay, I have a force of 150 pounds. So I'm going to take 512 divided by the length. The length I don't know. So I'm trying to solve for length, but I've got length down in the bottom of a denominator there. So let's deal with that. I don't like that being down there. So if I just multiply both sides by L, then this makes my setup a lot easier to solve. So now if I multiply there by L, I would have 150 L is equal to 512. So now I can just divide both sides by 150. The 150s cancel, and I have length is 512 divided by 150, which is about 3.41. Oh, use a complete sentence. Oops, I forgot to do that on mine. Okay, so the length is 3.14 feet. Oh, to the nearest inch. Okay. So this was in feet, but we need it to the nearest inch. So we want to get rid of feet. It has 12 inches. So we'll do a quick little conversion. 3.41 or yeah, 41 times 12 would be 40.9. And then that would round up to 41. The length needed (41 inches). Okay. Use a complete sentence. I'm not quite done. The interest earned is 100 or 1,400. And this one needed complete sentence. The resistance is 18.8 ohms. Okay, so these ones take quite a bit of steps, and then on this one, the directions say write a complete sentence with units.